Hello students, welcome back for class. Our today's topic is voltage level detector. Voltage level detector. This is also known as comparator. This is also known as comparator. So this is going to be a very important topic for you. So in previous class we have learned about zero crossing detector, that is whenever input crosses zero line your output was shifting the voltage level from different saturation levels, right? It was shifting from plus V naught sat to minus V naught sat. So let us see how the voltage level detector is going to be. So if this is your op amp, plus VCC minus VE, the input is applied for inverting terminal and let this be R1, let this be R2, then this will be another input. Here you have to apply plus VCC, plus VCC. Okay, let me write this VR2 here, R2 here. The voltage across R2, so let us call it as VR2. Okay, suppose we have given input here, let this be your input. Okay, let this be your input. How will be your output now? This is how your output is going to be now. This is our zero line, this is our zero line. Now what is VR2, positive voltage or negative voltage? It's going to be positive voltage. It's going to be a positive voltage because we have given plus VCC. So this is your, the dotted line what you see here is our VR2 voltage. The dotted line is representing VR2 positive voltage. Okay, now now let me draw your input here. Okay, all right. The red dotted line is representing our input. Okay, I know here the amplitude is less, same input is used here. I can increase its amplitude if you want. I want amplitude to show more there. Okay, now it is a little proportional. So well, the dotted line is representing input, the blue color that is dotted line is representing our VR2 voltage, right? Now let us see how your output voltage is going to be, right? When your input crosses zero line, it was supposed to go change your state, right? But here what happens, when your input crosses VR2 voltage, your output is going to change. I repeat, whenever your input crosses VR2 line, that is VR2 voltage line, your output is going to switch. Your output is going to change from V0 state to other V0 state. That is how, because your, like how your zero crossing detector works with zero line, here voltage level detector works with VR2 voltage. So here VR2 voltage will work as your zero crossing line. Okay, see how I draw here. Yes, here. So this is the point where it is crossing VR2, right? VR2 is your input process VR2 at this point, right? So this is what will decide your output will change at this instant. At this instant your output will change. That is, input is given to inverting terminal, right? So for this is positive input. What is this portion? This portion is positive. For positive input you will have yes, tell me. No, yeah, I had to correct it. So this is your input, this is your VR2 line. So this is the point where it is decided when the output should change. This point, this crossing, okay. So for before crossing this VR2, here it becomes positive, right? Here your input is positive. Before crossing VR2, it will act, I mean this portion, it will act as your negative. It will act as negative input. For negative input, you will have a positive output. If this is your negative, then for this you will have a positive output, that is plus V naught sat. And when your input crosses this VR2 line, your output shifts from positive and goes into negative saturation level, that is minus V naught sat. Okay. See, for negative input, positive output. For positive input, negative output, because input is given to inverting terminal. And output is shifting from positive to negative. I repeat, output is shifting from positive to negative whenever your input crosses VR2 line, VR2 voltage line, not the zero line. Okay, now see here, at this instant your input is changing from, once again it is crossing VR2 line, like it is going below VR2. The moment your input goes below VR2 voltage, your output shifts. Your output shifts and goes from minus to plus, minus to plus. And how long it will remain at positive? Until it will remain positive until your input completes all negative waveform, negative half cycle, and it should come and cross once again VR2 at this point. Till here you need to continue, and this is your output. This is your output. Understood? So your reference line is your VR2. VR2 is acting as a line which will decide when your output will change from its saturation level. Understood? Similarly, we can also have a voltage level detector with slight modification, which will be called as Smith trigger circuit. Okay, so that we will cover in our next class. So this is what a simple comparator, or we also call this as voltage level detector. The purpose of this particular circuit is that whatever your VR2 voltage is, suppose your VR2 voltage is plus 2, then your circuit will detect whenever your input is below 2 volts and whenever your input is above 2 volt. Okay, based on your plus 2 voltage, your output is shifting from plus V naught side to minus and minus to plus. So this VR2 can be any voltage. Okay, we can also have a negative VR2 voltage. Based on that as a reference, your output will switch between its saturation output voltages. Okay, hope it's clear. So let me have the next topic with next video.